going to do is start off with a reminder from last week. We looked at this, just that if anything was the same variable and exponent, we're able to add those together. And the exponents stay the same when you're adding. Now this is very different from something we did before where we're multiplying. So the hardest thing about what we're doing right now is not the arithmetic. You know that 3 plus 3 is 6. You know that 3 times 4 is 12. And x times x is x squared. It's just that you have to remember, okay, there's rules for when you're adding, and there's rules when you're multiplying, and they're not the same. You can't just start combining exponents on every problem from now on. You have to keep it straight on which is which, okay? And then also from last week, reminder about something like this. What is 3x squared plus x? Can that be simplified at all? No. So also knowing when not to do anything at all. So sometimes we can add things together. They have to have the same variable, the same exponent. Then we can add the coefficient. It's like counting. 3 x's, 3 more x's, there's 6 total. And this is multiplying, so we not only multiply the coefficients, but we add up the exponents, which are, in this case, both 1 plus 1 is 2. And then, of course, when you just say, no, you can't do anything at all. Trying to keep all this organized as you're going along is going to be the most important thing. When to use each word. So what we're going to do is we're going to go through some multiplying now. We did adding, subtracting. We're going to do multiplying, but there's also going to be some adding, subtracting later on. So we're going to put all this together into one single problem. This is all leading up to something much bigger. We're just working on skills right now. There's no reason or purpose for this problem right here. It's just that when we get to bigger real life problems, you're going to have to know how to do this right. So it's one of those kind of skills sections with no real context. But it'll have a purpose later on. Okay, so we're going to start off with something we already know, distributive property. That just requires you to multiply, right? So 4b times 5b would be 20, right? 4 times 5. And b times b is b squared. So again, knowing when we're multiplying, that makes a difference, so we add exponents, right? 4b times negative 8. Very good, 32b. Once again, these are different exponents. This is the b the second, this is the b the first. So those cannot be combined or added or subtracted, and you are finished. So knowing when to stop is just as important as knowing what to do. All right, go ahead and try number 2 on your own. Just jot down, check what's on the next. Okay, so we're just going to go back and forth on a lot of these. Try it out on your own, check us on, just make sure you got it. It's going to get more difficult as we go along, so check from the very beginning. Okay, so we just have, 7 times 8 is 56x. Right, 7 times 5 is just 35. There's nothing else you can do there. So next, let's just do it with fractions. 3 over 2, 3 halves times 1 half. 3 times 1, 3. 2 times 2 is 4, so 3 over 4p. 3 times 1 is 3. And 2 times 2 again is 4. No surprise, these are both multiplying by 1 half, so they both came out to 3/4. And again, we cannot combine those together. That's as much as you can do. Top times top, bottom times bottom. Go ahead and try number 4 on your own. So we should have just 3 over 2x plus 3 times 1 is 3. 2 times 3 is 6. Is that finished? No. Because 3 over 6 reduces. Now that's one of those things you'll be reminded of if you actually check with somebody right now. Maybe they did this and you didn't. You're like, oh yeah, I have to do that. Again, if you just kind of wrote something and said, I'm done, and I'm not going to check with anybody, this is where you don't do as well as other people because you don't check. So make sure you do check because there are little mistakes to be made, or in this case, not a mistake, but you just didn't finish the problem all the way. Okay. All right, let's kick it up a little bit. Now, we just multiplied one term by 2 terms. Now, when there's 2 terms, it's called a binomial. Anybody take a guess at what 3 terms would be called? Trinomial. So let's multiply to a trinomial now. It just means means 3 terms. So we're going to multiply 1, 2, 3 times, right? Shared property 3 times. 2 times 3a squared. 2 times a. And 2 times negative 2. So same thing, just distributing 3 times, right? Same thing, go ahead and get number 6 to go. So I see 2x to the third plus 4x squared, right? Plus 6x. So everything went up by 1 on the exponents because this is next to the 1, so we just increase each of these by 1. We got 3, 2, 1. Your answers, by the way, should always be in descending order, which just means the highest exponent is always first, and then you just count down all the exponents. 2, 3, then 2, then 1. Same idea for number 7, and distribute 3 times. So 5 halves times 4 thirds would just be 20 over 6, right? 5 halves times 1 half. 5 fourths. Okay. And one more. 5 halves times 3 halves. We have negative 15 fourths. Is that problem finished? No. What can I do? Simplify what? Yeah, 20 over 6 reduces, so reduce that. So we got like 2 goes into both of those, so that's going to reduce to 10 thirds. So everything else is already reduced, stays the same, but we do have to reduce everything. So always look for those opportunities. Remember, do not ask me, do we have to reduce it? No teacher has ever said, no, just don't finish the problem and go ahead. Okay? They've always said yes to that, so no reason to ask the question in the first place. Yes, always reduce. Okay. All right, give number 8 a go. See how that is. Okay. Put it on. Now you'll notice that we multiplied one term by 2. So, and that 1 times 2 equals 2 terms. So 1 times 2 equals 2 terms, and then we multiplied one term, right, by 3. 1 times 3 is 3 terms for our answer. So now we're going down to a binomial times a binomial. So there's 2 terms for each of these, right? That's what binomial is. So 2 times 2, that means there are 4 multiplications. Okay? 4 multiplications. So what we're going to do first is multiply the 3n by each of these. 3n times n, 3n times 1. That's 2 of them, that's halfway, but then we're going to multiply the 1 times both of them. Okay, so there's 4 total multiplications. You can always calculate beforehand how many times we need to multiply by counting how many terms in each parenthesis and then multiplying those times. Let's do the first one. 3n times n. Alright, so we have 3n second. 3n times 1. 1 times n. Right? Is n. And then 1 times 1. So 4 multiplications, got your answer? Now, is this simplified? Is this finished? Oh. So going back to what we reviewed at the very beginning, if you have the same variable and the same exponent, you can combine those together. 3x plus 3x is 6x. So what we got here, we got 3, there's only 1 n squared, so that won't combine with anything. There's only one number, that won't combine with anything. But there is a 3n and a 1n, if you will, that will combine and make 4n. So you do have to simplify. So we're doing the multiplication and the adding and subtracting rules all together at the same time. So this is where, believe it or not, it will start getting somewhat difficult, not because the arithmetic's hard. We're doing 3 plus 1 is 4, but just remembering, okay, when do I add exponents, when do I just combine and add coefficients, and be very conscious of what, are you multiplying or are you adding? Okay. Go ahead and try, let's do one more together, so number 10. need to do this forever, but it helps you follow it first. Keep in mind, what we're doing right now could be written as 3x plus 1 squared, right? We're doing 3x plus 1 times 3x plus 1. Hey, any quick guesses of what this equals? 1, 2, 9x to the second plus 1 times 1 is 1. Let's test that hypothesis by showing all the work. 3x times 3x, 9x squared. 3x times 1, 2x. Now let's do the second half. 1 times 3x, and 1 times 3, and 1 times 1, 1. Once again, the middle terms combine. 3x plus 3x is 6 plus x. So, was our prediction right? Is the correct answer? Oh. Really fast, you see, you can imagine somebody looking at this and saying, oh yeah, it's just that, because I do this, not showing work, it's too easy to get wrong, and then, of course, you can see, yeah, it goes wrong. So, definitely show all the work, do not skip anything. And we'll go more into depth on why this is once we get the hang of this. Okay? But definitely show all the work. 3x times x, so I'm multiplying, so I'm adding the 2x on 1 plus 1, and multiplying. And then here, when I was adding, I didn't get to because I was adding. Different rules for adding and subtracting. Okay, so go ahead and try 11 and 12. Showing all the work, not taking any shortcuts, and then checking with somebody just in case you make a small error. Now, on these, I'm going to show you the same way I did before. It's just distributive property multiplying. So, 2 steps, right? 2 steps here, so 2 multiplications, and then 2 more multiplications here. Basically, just make sure you multiply everything by everything. 6x has to get multiplied by everything here, and so there's the 1, just individual steps. So 6x times x, 6x squared. We're multiplying, so we're adding the next one. 6x times negative 8, negative 48. 1 times x, x. 1 times negative 8, 1 times negative 8 is negative 8. And of course, we have some like terms that we're living with here. So negative 48 plus 1 is just negative 40. Negative 40 is 7. So the first term and last term stay the same. Okay? Now, here's another way of looking at it. If you started doing this problem and you weren't sure what to multiply by what, and it's getting confusing, and you start doing all your multiplications, but then you end up with only 3 of them instead of 4, there's another method, more visual, where you multiply, like a multiplication table, like this. You set up each term in each box. And then the empty boxes will just be the product of what's in that row and that column. So in this empty box, you'll put whatever 6x times x equals. And it kind of tells you, okay, here, what I put here, oh, it's whatever this times this is. Okay, and that will work as well. And it's the same steps, of course, not the same answer. So 6x times x is still 6x squared. 6x times negative 8 is still negative 48x. So those the same first 2 terms here are the same here. So it's not like it's less work or faster or easier. It's just another way. X times 1 is just x, and then 1 times negative 8, negative 8. And just like we combined these two to get negative 47, it's just on a diagonal here. So, but the nice thing about this is that it really leads you to complete the problem. You won't move on to the next step until each of these squares is filled up. So you won't accidentally, like, we'll only do 3 multiplications for some of you might only do like, you know, these two and then the last two. You're just doing two multiplications, multiplying the first together and then the last together and ignoring the whole inside. So you can try the box and see if that works for you. It's a little bit different, but it's all about what gives you the right answer and what makes sense, as opposed to well, what's faster, what's quicker, and it doesn't matter if it's fast if you don't get the right answer, right? So you can always go through, use this box method, right? And we know in this empty box we'll have 30, right? 6 times 5 is 30. V times V, second. In this box we'll have 5V times 7, so 7 times 5 is 35. Over here we'll have negative 8 times 6, negative 48V. And then here we'll have negative 8 times 7, negative 56. And then, of course, on the diagonal, you see what should be combined together. So we have highest exponent first, so we have 30V for the second. Negative 48 plus 35 would be negative 13V, and then bring down the negative 56. So if you like this method, maybe try it out. If you use the first method and you didn't get the right answers, try using this, see if it works. And remember, the way you pick your method is the one that works the best for you. Don't just pick one because, well, I think I like it because it looks nice. But what gives you the right answer? Right. All right, so let's step it up one more notch.
But I still don't understand.
Go to the back. So here we have two terms, and now we're multiplying the binomial, 2 terms, times a trinomial, 3 terms. So altogether we're going to have a total of 6 multiplications. We got to do 6 now, right? We got to do the 4x times all 3 of them, so that's 3 of them, and then I have to do the negative 2 times all 3 of them. So that's how we get 6 multiplications. If you need to, draw the lines, so that way you're not forgetting anything. I'm going to show you how to stack these in a way that make it easier to combine all the terms as well. So follow along. Okay. 4x times 3x squared, so 4 times 3 is just 12. X times x squared is x to the third. 4 times negative 7 is negative 28. There we go. And x times x is x squared. 4x times 7 is just plus 28x. Halfway done. We got 3. We need 3 more. So do the second term here. Negative 2 times 3x squared. Now my answer is going to be have an exponent of x squared. So when I do this, I'm actually going to write it underneath the other x squared, because those are what combines, is when they have the same exponent and same variable. So I'm going to combine this. I'm going to write it right underneath here. Okay? And then continue that pattern. Negative 2 times negative 7, got positive 14x. Okay, negative 2 times positive 7, right? Just negative 14. Notice how there's nothing out here because we didn't have just a number by itself. So now everything is lined up vertically, right? That combines together. Makes it a little bit easier to finish these up. So I'll have a 12x to the third because that doesn't combine with anything. Negative 28 and negative 6. We have negative 34. 28 and 14 is 42. And then again, the number here has nothing to combine with, so just bring that down. You can kind of tell there's a pattern. The first and last terms, whether what regardless of what problem we're doing, seem to be the same. Seem to be the same. They don't combine with anything. It's the stuff in the middle where you have to do all the combining. Okay. So there's your full answer. You can see how all the exponents count down. I have the x to the third term, then the x squared term, then the x. Do not go off the coefficients. Go off by the exponent. Okay. So highest exponent first, then count down. So we wouldn't rewrite it and put 42 and then 34 and then 12 or anything. All right. So let's try one more. Okay. Try one more, number 15, but do a 3 by 3. So we're going to do 3 terms, trinomial, times a trinomial. So that means we have 8 terms all together. 9 terms all together. We have, multiply these 3 first. Okay. So 4b squared times 3b squared. 12b to the 4th. 2 plus 2 is 4. 4b squared times negative 2b. 4 times negative 2. Negative 8. b to the 2nd times b. b to the 3rd. Okay. 4b squared times negative 2. So 4 times negative 2 is just negative 8. And then variable stays the same. So that's a third of the way done. And we have to just repeat it. It's very repetitive, very detailed work. You have to make sure every little exponent's correct. So now let's do the 5b. So let's do 5b times 3b to the 2nd. So 5 times 3 is 15. b to the 1st times b to the 2nd is b to the 3rd. So I know I'm going to write my answer here underneath the other b to the 3rd. And again, 5 times 3 is 15. Okay. 5b times negative 2b. So 5 times negative 2, negative 10. b times b is b to the 2nd. So again, always making sure these are the same variables and same exponent. And lastly, we have 5b times negative 2. So negative 10b. Okay, 2/3 of the way done. We have one more set of 3 to go. So we'll do 5 times 3b, which is 5 times 3b is the 2nd, which is 15 b to the 2nd. Notice how I write it underneath the other b to the 2nds. And then 5 times negative 2, another negative 10b. And 5 times negative 2, there you go. So we're adding this whole thing up, just like a regular old addition problem. And I made it so everything in each column, right? Everything in each column has the same variable and same exponent. And once again, you notice how the ends stay the same. So there's no other b to the 4th, so just bring that 12b to the 4th down. 15 minus 8 is 7. b to the 3rd, same exact exponent, right? So that does not change when you're adding, subtracting only. We're multiplying, the exponents change. Adding, subtracting stays the same. Okay, we have negative 8, negative 10, and positive 15. Do the arithmetic and you get negative 3b to the 2nd. And negative 10 and negative 10. Negative 20. And then once again, the last term, just like the first term, nothing to combine it with. That. Okay. So always think about what's the easy thing here, what's the hard thing. The hardest part is really organization. If you're used to showing your work, this is like, really, that's all you have to do? If you're not used to showing your work, you just want to kind of speed through it and not write anything down, It's hard not because it's math, it's because you're in a big hurry and you want to find some shortcut that's, sure we have to take this, long problem, which long means about 50 seconds long, and you're trying to cut it down to 30 seconds and do half the work, and it ain't going to happen. So slow down, show everything neatly and organized, and you'll be surprised that doing these correctly has little to do with arithmetic when we're multiplying and adding from the 3rd grade. That's as hard as it gets. We have to multiply single-digit numbers and add single-digit numbers. So it's not the math. It's just keeping everything organized in columns like you see that. So practice on the organization. You'll see that it's actually a lot easier than you might think if you're struggling with this. Okay? So go ahead and try 15 and 16. I'm also going to do the box method here just so you can see that part if you prefer that way. Okay? But go ahead and do 14 and 16 on your own. If you're still watching me do the box method, you can see how it's the same amount of writing, but it just leads you to fill in each box so you know when you're done with all your multiplications. What we had in columns before is now on the diagonals. You end up with the same answer. So either method works, but both require you to do detailed work in an organized way so you don't miss any little thing.